Okay, now let us see the CPU scheduling algorithm, that is first come first serve with arrival time. So far we have seen some examples without arrival time. That means we are assuming all the process arrives at the time 0 in the ready queue. Now we are giving some different arrival time. Listen carefully. According to this first come first serve problem, we are having three process P1, P2 and P3. Already you know burst time. Process P1 burst time is 4, P2 it is 8, P3 it is 3. Now importantly you see arrival time for each process. Okay, all time must be considered as seconds, as you know. Okay. So what does it says? At the time 0, P1 enters the ready queue. Okay, listen carefully. Now consider this as ready queue. So at the time 0, P1 enters the ready queue. After 2 seconds only, okay, this is not Gantt chart. After 2 seconds, ready queue. After 2 seconds only, P2 is entering into the ready queue. Okay. After 1 second, that is at third second only, P3 is entering in the ready queue. So what does it mean? When P1 enters ready queue at 0, P1 will be allotted the CPU. Okay, until 2 seconds, P2 is not there, only P1 is there, so it will execute. After 2 seconds only, P2 will come. So what does it mean? This time is not waiting time for P2, because P2 not yet arrived at ready queue. So you should not consider these 2 seconds as waiting time for P2. Okay, from second only you can consider what is the waiting time until it enters into the CPU. Listen this carefully. Okay, we will see the Gantt chart first. Okay, at time 0, how many processes are in ready queue? Only one process is in ready queue. So that process will enter into the CPU P1. According to first come first serve, P1 will complete its job at 4 seconds. Okay. Now the operating system will go and see the ready queue. Now 4 seconds completed. When after the completion of 4 seconds, how many jobs are there in the ready queue? P2 and P3 are in ready queue. Now it will consider first job of the ready queue, that is P2. P2 will enter into the CPU. Okay, how long P2 will execute? 8 seconds. So until 12 seconds it will be in the CPU, and finally P3 will enter into the CPU. P3 will be executing for 3 seconds, so total of 15 seconds. Okay. Now listen carefully. How to calculate the waiting time for each process? Already we know waiting time equal to completion time minus arrival time plus CPU burst time. Okay. Now what is for process P1? The completion time for process P1 is 4. 4 minus what is the arrival time? That is 0. Plus what is burst time? 4. So equal to 0. According to Gantt chart also, at the time 0, P1 enters into the CPU. So P1 is not at all waiting. Directly enters into the CPU. So waiting time is 0. But when we consider for process P2, what is the completion time for process P2? 12 minus arrival time is 2 plus CPU burst time is 8. So 12 minus 10 equal to 2. Okay, normally in our previous example, we will consider as 4. Okay, because completion time minus arrival time plus burst time. Arrival time will become 0. So 12 minus 8, it will be considered as 4. Now we are having arrival time. So that is added here. 2 plus 8, 10. 12 minus 10 is 2. What is for process P3? Completion time is 15. Minus arrival time is 3 plus burst time is 3, that is 15 minus 6 equal to 9. Okay. Now let us see logically. According to our previous example, let us see concept wise how to calculate the waiting time. See, P1 enters the CPU and immediately alerted, P1 enters the ready queue and immediately alerted the CPU. So P1 at a waiting time is 0, there is no any problem. Okay, listen carefully. At time 2 seconds only, P2 enters the CPU, correct? When P1 is executing in CPU, after 2 seconds, okay, P2 enters into the ready queue. So from this we have to calculate 2, and here P2 is entering at 4, so 4 minus 2 is 2. Okay, now consider for P3 at time 3. Okay, third second P3 enters the ready queue. So when it is given the CPU, 3 at the 12th second it is given the CPU. So 12 minus 3 is 9. Logically speaking, this is the formula what we are applying for calculating waiting time. Okay, now as usual you can calculate average waiting time and average turnaround time. Okay, now look after turnaround time. Formula is simple: completion time minus arrival time. What is process P1? Completion time is 4 minus arrival time is 0, so it is 4. Process P2, completion time is 12 minus arrival time is 2 equal to 10. Process P3, completion time is 15 minus arrival time is 3 equal to 12. Okay, now we will see logically this turnaround time also. After 2 seconds, P2 is entering into the CPU, and 12th second it is completing the work. So 12 minus 2 is 10. Okay, at the third seconds P3 is entering the ready queue and it is completing at 15th second. So 15 minus 3 is 2. So logically also the same answer you are getting.